In October of last year, a mysterious event took place in the skies over Connecticut. A double meteor streak that many officials quickly dismissed as a simple trick of the light or a standard atmospheric refraction. But for those watching closely, the footage told a different story. It appeared to show a secondary object following a meteor directly into our atmosphere, maintaining a specific trajectory as if tethered to or trailing the larger fireball. This raises a fundamental question that challenges our current understanding of orbital mechanics. Why would this happen? Even if we set aside the idea of a trick of light and consider that this might be some form of unidentified flying object, what is the strategic point of following a meteor into our atmosphere only to watch that meteor burn up and disintegrate? It seems like a waste of energy, unless the meteor itself is part of the plan. Interestingly enough, just a few days ago, Avi Loeb reported the discovery of 2 new interstellar objects that impacted our atmosphere fairly recently. One of these events occurred in July of 2022, and the other happened almost exactly 1 year ago, on February 12, 2025. That particular object, CNEOS 25, is extremely suspicious. It appeared in our atmosphere a mere 5 months before we detected the presence of the massive interstellar interloper known as 3I Atlas. The timing is almost too perfect to be a coincidence, but why are these smaller objects significant? How do we know they are just ordinary garden-variety interstellar meteors passing through the void? Well, if they are indeed ordinary interstellar meteors, the math suggests something truly astonishing and perhaps impossible. It would mean there are far more interstellar meteors in our solar system than any astronomical model ever thought possible. If that is the case, we have to rewrite every single astronomy textbook regarding the density of interstellar material in the galaxy. And if that is not the case, if there aren't actually trillions of these objects drifting aimlessly, it means that these specific objects impacted our atmosphere by design. They weren't just passing through, they were aimed. To understand the weight of this, we have to look at the history of 3I Atlas. It has been a little while since we've discussed the specifics of that object, but today's discovery changes the context of the entire conversation. We are talking about interstellar UFOs that entered our atmosphere in very recent years, specifically timed around the arrival of larger interstellar visitors. When we see an object hitting the atmosphere just months before a major discovery like 3I Atlas, we have to speculate about the possibility of these smaller objects being scout probes. Are they advanced guards sent ahead of the main body? Why would we think there is anything unusual about them or suggest they have a technological point of origin? The reason is statistical. The fact that these things exist in our records at all is a mathematical anomaly. Over the last decade and a half, we have had at least 3 and possibly 4 confirmed interstellar meteors impact our atmosphere. That is an incredibly high frequency for objects that do not belong to our sun. This suggests one of 2 things. Either they are hitting us by design, or the solar system is a shooting gallery filled with interstellar debris. Consider the odds. Unlike ordinary meteors that are bound to the sun in elliptical orbits, giving them thousands or millions of opportunities to eventually cross Earth's path, interstellar objects have only one chance. They are on a hyperbolic trajectory. They fly into the solar system, zip past the sun, and fly out, never to return. The probability of one of these one-shot objects randomly hitting a tiny speck like Earth during its brief transit is infinitesimally small. For us to have seen as many as we have recently, the sheer volume of these things in the solar system would have to be mind-blowing for the math to make any sense. In a groundbreaking new paper co-authored by Avi Loeb and astronomy postdoc Richard Kleda, they report on the identification of 2 previously unrecognized interstellar meteors hidden within NASA's CNEOS Fireball database. By using a sophisticated new type of computer model, they identified 2 specific events that robustly exceeded the escape velocity required to leave our solar system. The first, CNEOS 22, was detected on July 28, 2022 in the eastern tropical Pacific. It exceeded escape velocity by 8.7 standard deviations, a statistical slam dunk. The second, CNEOS 25, impacted on February 12, 2025, exceeding escape velocity by 5.5 standard deviations. For both of these events, the researchers ran 1 million different simulations, accounting for every possible variable. Not a single one of those million possibilities yielded an orbit that was gravitationally bound to the sun. In other words, after measuring the trajectories and the speeds, they found that neither of these meteors could have originated in our solar system. They were travelers from deep space. The discoveries of Oumuamua, 2I Borisov, and 3I Atlas have already proven that interstellar objects larger than a football field transit our inner solar system. While these massive bodies are large enough to be caught by telescopes, smaller bodies, those just a meter or two in size, escape detection until it is too late. They only reveal themselves when they slam into Earth's atmosphere, creating fireballs that burn brighter than the stars. The CNEOS Fireball Database, maintained by NASA's Jet Propulsion Laboratory, is a global catalog that uses U.S. government sensors, the same ones used to monitor for nuclear launches, to track these impacts. These sensors provide the velocity vectors needed to calculate whether an impactor was a local rock or an interstellar visitor. Previous reports focused heavily on IM-1 from 2014 and IM-2 from 2017. Interestingly, IM-2 hit the atmosphere the same year that Oumuamua passed through our system. We are seeing a distinct and repeating pattern here: interstellar meteors impacting Earth in the same years that large, mysterious interstellar objects are transiting the solar system. While some astronomers raised concerns about the accuracy of older data, claiming the velocity measurements might be flawed, the situation improved substantially in 2025. With a new computer model that cross-matches NASA events with independent ground truth networks, we can now distinguish genuine interstellar trajectories from simple measurement errors. This new calibration provides an empirically grounded basis for a statistical assessment. When we analyze the complete CNEOS catalog, looking at latitude, longitude, and velocity, we see that these objects are not part of the standard background noise of the solar system. After removing the influence of Earth's gravity and Earth's own speed around the Sun, these objects still show a positive, heliocentric specific energy. They were moving too fast for the Sun to ever catch them. If you look at the data graphs, IM-1 remains the fastest relative velocity recorded, making it the best candidate for a technological probe. But CNEOS-22 and CNEOS-25 are right there with it. We now have two interstellar objects hitting Earth in the exact same years that Oumuamua and 3I Atlas arrived. The odds of that happening purely by chance are about 6%. While that's not impossible, it means there is a 94% chance that this is not a random coincidence. Where did they land? CNEOS-22 hit the Pacific Ocean off the coast of Peru, while CNEOS-25 hit the Barents Sea in the Arctic. The Barents Sea location is fascinating because it hit a relatively shallow area. This makes the prospect of debris retrieval much more realistic, though the Barents Sea is notoriously difficult to navigate and search. But the question remains, why would a world-class scientist like Avi Loeb want to spend millions of dollars scouring the ocean floor for these remnants? It's because if these are just ordinary rocks, then the implications for the galaxy are terrifying. To have this many random hits, there would have to be 35 million meter-scale interstellar objects within the orbit of the Earth at any given time. That's 100 trillion metric tons of interstellar material just in our immediate neighborhood. If you scale that up to the entire galaxy, the amount of stuff floating between stars would be 1,000,000 times higher than any previous estimate. It doesn't add up. There is another possibility, one that many in the scientific community are afraid to say out loud. If the population isn't that dense, then these things are hitting us by design. This is not an accidental occurrence. They are arriving in our atmosphere because they were sent here. Think back to that object trailing the meteor in Connecticut. If you wanted to send a small, delicate probe into a planet's atmosphere, how would you do it without a massive, heavy heat shield? You might attach it to a naturally occurring meteor. The meteor takes the brunt of the heat, acting as a sacrificial shield, and as it disintegrates, the probe detaches and slows down, eventually becoming one of those orb UFOs that our military sees so often. This would explain why we see a trailing object. It could be a probe that was protected during the most violent part of the entry. If we believe that 3I Atlas is a modified comet or asteroid containing technology, then it stands to reason that smaller meteors could be used as delivery vehicles. These objects are roughly the size of the drones or orbs reported by pilots. They don't need to be massive ships, they just need to be small sensors. The only way to know for sure is to find the debris. When Avi Loeb went looking for the remnants of IM-1, he didn't find typical meteor fragments. He found spherules with a chemical composition that looked artificial and unique compared to anything in our solar system. Will he find the same thing in the Barents Sea or off the coast of Peru? If these objects are fragments of a larger parent body, or if they are independent probes, their composition will tell the story. Studying these objects is the only way to move from speculation to science. Even if they turn out to be natural, they are still pieces of another star system. They are messengers from the deep, but as the data continues to mount and as the timing of these impacts continues to align with the arrival of massive interstellar objects, the random rock theory becomes harder and harder to defend. We may be witnessing a coordinated survey of our planet by an intelligence that uses the natural debris of the galaxy as a cover for its technology. The math is telling us something is wrong with our current models. Either the galaxy is far more crowded with debris than we ever imagined, or we are being visited far more frequently than we are prepared to admit. The fact that these discoveries are happening now with better models and more sensitive sensors suggests that we are finally beginning to see the true nature of our local space. It is no longer just a void filled with the occasional rock, it is a highway for interstellar travelers, and Earth seems to be a very popular destination. As we look toward future expeditions to the ocean floor, we must be prepared for what we might find. If we pull up a piece of metal that shows signs of manufacturing, everything changes. Until then, we continue to watch the skies, monitor the fireball databases, and look for the patterns that the rest of the world is too busy to see. The objects are here. They are moving at speeds that defy our sun's grip, and they are arriving with a frequency that suggests a purpose. Whether we call them meteors or probes, they are the key to understanding our place in a much larger, much more active interstellar neighborhood. Stay focused on the data, and stay curious about what lies beyond our atmosphere.